Hi. ಏನಿಲ್ಲ ಸರ್ ಯಾವಾಗ ನೈಟಾ ನನ್ ಕ್ಯಾನ್ಸಲ್ ಬಂದಿಲ್ಲ ವಿಲ್ ಟಾಕ್ ಮೇಡಮ್ ರೈಟ್ ಗುಡ್ ಮಾರ್ನಿಂಗ್ Right. Good morning. Why less students are there? Started preparation. Okay. Today I'll do the revision class. The regular syllabus will move to the after test. Okay. Right. So now we can see the syllabus here. What is there? First one is called the insertion sort. First one is called the insertion sort. So what is the insertion sort? Briefly I'll tell and go all the problems. Insertion sort. What is insertion sort? Insertion sort also a sorting techniques. So what will happen? Suppose the ith element, if you want to sort it, is nothing but I minus 1 locations will be checking and where the elements will be. So what will happen? Up to 0 to ith element means 0 to I minus 1 elements will be already sorted. So ith element you want to sort it out means what will happen? It will be finding that particular location where the elements to be inserted. For example, you have, for example, if you are having the elements called like 20, 35, 14, 28, 18, and let us say the example 21. If you are having the element something like this, what will happen? First element, when you are taking, this is already sorted. Now the second element you need to take it. So what will happen? 35 is there. So 35 will be comparing with the previous element. What will happen? So 25 already sorted. 35 you want to sort it, so greater than that element 35, so no need to do any operation. So this is as it is. Now 14, 28, 18 and 21. Now what will happen? Now you want to sort it out, second element over. Now you want to go for the third element. Now what will happen? You need to check it out with this. So what will happen? 14 is less than 35. So 35 move to the next location. So 35 will be moved to this location. Now this will be taken to the temporary location. So now you will be comparing with 20. So 20 also same thing. 20 will be moved here. Now you don't have any previous elements. 14 will be placed here. That is what will happen. Copy the remaining elements 28, 18, 21. Now what will happen? You need to take the 28, compare with, you are taking out the temporary location to 28. So what will happen? You are comparing with 35. So 28 is less than 35. So 35 will be moved to here. Now 28 is less than 20. No. So no need to check the previous values. 28, place it here and copy the remaining values as it is. Now 18 to be taken. Now 18 to be taken is nothing but what will happen? So 18 to 35 will be compared. So in this case, what will happen? Condition is true, 35 will be moved here. Now what will happen? 18 and 28 will be compared, 28 will be moved here. Now what will happen? 18 and 20 will be compared. So condition is true, 20 will be moved here. Now 18 and 14 will be compared. What will happen? So condition is true, 14 condition will become false. So now 18 will be copied it here only. So now 14 elements as it is and 21 as it is. Now what will happen? 28 you want to compare it and these two values will be checked. Condition is true, 35 will be moved. Now what will happen? 21 and 28 will be checked and 28 is bigger element, move to the next location. Now 21 and 20 will be compared and condition will become false. In this case, what will happen? 21 will be copied here. The remaining values you copy it as it is. This is what the sorting order. Now what will happen? The worst case time complexity is what will happen? 18 if you take it, what will happen? The elements are in descending order. It will work like selection sort and the worst case time complexity is nothing but double summation, two loops, it will be working perfectly. So n into n. So what will happen? Theta of n squared divided by 2, that is what the time complexity is. That is what the first problem. And the next one is called BFS. BFS. So students, if you have any specific topic doubt, you tell me, I'll tell that one only first. Anybody is having specific topic doubt? Or I'll go briefly, all the problems, I'll solve it and go. Which way you want, you tell me, I'll tell you that way one. I thought I can solve it briefly. If you want that way, I can go ahead the same way. Or if you have any particular problem to be discussed, I'll discuss that one only. You have to say. Otherwise, whatever I assumed, I will go according to that. Students, Arjun. Arjun. Shall I go the same way? Right, I'll go the same way only. Now, you have the... Shall I solve the same order? Alright. So now, the second one is called the... You have BFS.
Yes, sir.
Right. So I'll take bigger problems. A, B, C, D, E, F, G. Okay. So starting node. Which one I'll take? I'll take D. Exam also they will be asking any node which one they want. Okay. So starting node is D. I'll solve it directly the answers, but whatever I have done in the class, the similar fashion you need to write it in the examination. All the steps you need to take the Q and what are all the elements you are taking first based on the adjacency matrix. Then you have to delete first in first out. Then from that element, do you have any elements is there or not? You have to check it out. All the steps I'll be writing in one step only here, but in examination you write it the elaborate. So I'll write something like this. See here, A, B, C, D, E, F, G. Q I'll take. I have written the first node is called the D. First node is called the D. So from the D, according to the adjacency matrix, which one you have the connected? So which one you have connected? D to A is connected, D to B is connected, D to C connected, D to F is connected. So BFS is nothing but what? All adjacency. Q like Q will be working. So D to A connection is there. First one that should be written to the Q. Next, so D to B. Next, D to C is there. So that also write it in the Q. Next, what will happen? So D to F also will be written. That also to be written into the Q. Next, what will happen? Which one will be? This is now popped out. Next, A to be popped out. Second one. So when you are A popping out adjacency matrix, A to B is there. If I draw this, I will be getting cycle. A to C is there. If I draw this, I will be getting cycle. Next one is A to D, already written the diagram. So no nodes will be taken from the A. So next, pop out the B element, third one. When you are popping out B to A adjacency matrix, wherever the connection is there, I will be reading, remaining I will not be reading. B to A is there. If I draw this, I will be getting cycle. B to D, if I draw this, already drawn the cycle. Next one is B to E is there, B to F is there. So B to E, I can draw it. So write it to the E into the Q. Next, B to F connection is there. If I draw this, I will be getting the cycle. So it is not possible to do it. Now C pop out. When you are C popping out, adjacency matrix C to A connection is there. If I draw this, I will be getting cycle. C to D already written. That's all. Next, what will happen? You need to pop out the F. When you are popping out F to B is there. Adjacency matrix F to B, if it is there, if I draw, what will happen? I will be getting the cycle. So F to next is F to D already written, F to E. When I'm saying, you need to observe the main graph. Students, you need to observe the main graph. If you have doubt, please stop me and ask me. So F to E cycle you will be getting. Next is F to G is there. 1 second. All right, F to G is there. So now you write it to the Q, that also G. Next, what will happen? E to be popped out. When you are popping out E, so check it out any other non-connected graphs. So now E is there. So E to B is there, already connected. E to G, if I draw this, I will be getting the cycle. No need to do anything. Next, pop out the last element. G. So do you have any nodes? No. So the graph is connected or not is nothing but all the nodes, whether you have covered or not, A, B, C, D, E, F, G, H. So the graph is connected. Graph is connected. This is what the diagram will be written for the BFS diagram. Already I have told you the algorithm also. Now the same diagram with the same node I will be doing the DFS. Same diagram I will be taken the DFS. So now see here is today I'm not asking any questions. I'll be telling and go because I have to solve maximum problems. I'll try to cover the maximum problems because if I am asking you to tell the answers, it will take more time. I cannot solve the more the problems. If you have doubts, please stop me. Now the same diagram I'll be starting with the D only. So write first diagram as it is. So A, B, DFS. Write the heading DFS. Same diagram. Above diagram A, B, C, D, E, F, G. Right. So now you have to do like this. You have to start with A only. Now adjacency matrix A to D. Starting node is D only. Starting node is D for this also. DFS diagram also. Now D to A is there, D to B is there, D to C is there, D to F is there. So it will be connected D to A only first. So D to A. Next you have to start with there only. So even you can write the stack. This you have to write it in the examination. D. Next A. So now what I told you is from A it will be starting. A to B connected, A to C connected. Now A to B you can draw it. P. Next you have to start with B only. So B to E is there, B to F is there, adjacency matrix, B to E will be taken first. Now you have to draw with the B to E and write into the stack that element E. Now you have to start with E. So when you are starting with E, E to F is there, E to G is there. Now element adjacency matrix according to that E to F will be there because when you are putting into the loop, first element will be taken. So E to F will be taken. Next is that you put it into the stack. Now F. So F, whenever you are having adjacency matrix, F to D is there, F to G is there. So F to D, if I draw, I will be getting the cycle. So that I will be taking to the other element is called G. So you draw the line F to G. So that is called the G. Now what will happen? Now what will happen? G elements, you have to check it out. So from G, do you have any unvisited nodes? No. So even unvisited nodes like nothing is there. G to E is there. If I draw, I will be getting the cycle. So any other possibilities? Pop out G first. Next, pop. Next is come back to the F. Do you have any unvisited nodes? No. Pop out the elements. Now come back to the E. Pop out. Come back to the B. Pop out. Come back to the A. Do you have any other nodes? Unvisited nodes? Yes. So A to C is there. So connection A to C is there. Now write it to the A to C. A to C. So now that will be once again move into the stack. So now do you have any unvisited node C? No. This to be pop out now. Next, what will happen? Check with A once again. Do you have any unvisited nodes? No. Pop out. Next is come back to the D. Do you have any unvisited nodes? No. Pop out. So this is what you have to do the operations using DFS. So if this diagram, entire diagram is right, you will be getting the full answers. Otherwise, no. This is what the final diagram. So you write it the other way also, like tree way also, you can do it, no problem. So one more note is this graph is connected. Suppose in examination, if they ask you to do something like this, A, B, C, D. Like this, if you are having, B is the starting node. Starting node is, if I take B, you can take any node. So in examination, if they give you the starting node, which one, that one to be taken, that's it. Now B, what will happen? So write the nodes as it is. So B to A can connect it. So A to C connected. So now pop out to C, pop out A, pop out B. That's all. So now you have four nodes. So matrix also you are entering 4 by 4 matrix, and you are written only kind of n minus, when the graph is connected. I told you n minus 1 edges. So suppose this is called n. How many edges should be there? N minus 1. So n minus 1 is nothing but 4 minus 1 is 3. So now you have only, this is called 1, this is called 2. So this is not connected. So graph is not connected. That's what you have to write it in the laboratory program also. One is connected, one is not connected. That's what I told you. So any graph related problems in the laboratory, you need to enter first graph according to that matrix, then matrix to be entered, then only you will be getting the full marks. Otherwise, no. So I was telling to Sunil last lab. So he was entering randomly. So that is not the way of entering. So you need to enter the first graph. Right. So spanning tree is nothing but any graph if you want to draw without BFS, DFS, you can draw any number of spanning trees. So to come out the conclusion, one person used using the stack, one person is using the queue. So now you see the diagram for this and this. See here is the graph is A to D to A is there, D to C is there, D to B is there. Next you can write the order also in the examination, no problem. Otherwise you can leave it from here also. But now in this case, what will happen? See here, this graph is totally different and this graph is different. But if Y draw or X draw, Y draw, Z draw, you will be getting the same graph only. In this case, his graph is connected. So examination, they will be asking whether the graph is connected or not. That's it. So that is what the BFS and DFS. Now we'll move to the topological sorting. So topological sorting is nothing but I told you already, you have the two methods. One is called the source removal method, one is called the using the stack. So like DFS you have done, I'll tell you the source removal method only. So topological sorting. Topological sorting. Right. If you're having this, which one to be taken first? C4. So first one is delete C4. If you delete C4, what will happen? Remaining diagram, you write it. C5 will be there, and you will be having like this, and you will be having like this, and C to C1. So these were the first one. Now what will happen? Delete C4. Where you don't have the in degrees, you need to take it. That's what I told you. So now you don't have the in degrees is nothing but C5. So now delete C5. Right. Now P3. So now what will happen? Now delete C5 means what will happen? The remaining node is C1, C2, C3, and the graph will be like this. Now what will happen? Already you have the previous one is where you don't have the integration is nothing but C3. So now delete C3. Now C1 is there, C2 is there. Now what will happen? Delete either C1 or C2. So I'll delete it first C1. Now what will happen? You have only C2. Next is delete C2 also. Now the order is first one is called, what will happen? First one is C5, sorry, C4. Next is C5. Next is C3. Now you have C2 and now what will happen? You have C1 and C2. So the order is one root is nothing but C2 and C1. One more order is C4, C5, C3, C1, C2. Both are possible. So both the roots you can write it, or sometimes somebody will write it C4, comma C5, C3, and in this case C1 comma C2 or C2 comma C1. This is what the order can be written for the topological sorting. So this is what the topological sorting. Next. Generation of the permutations, and this one only for combinations and permutations. So two ways. Next is called the Prim's algorithm. Okay, I'll take simple diagram so that I can solve another two problems also. 5, 3, 2, 6, 1, 4, 7, 8. This is what the Prim's algorithm. Spanning tree. So always I told you to take the first node only. So see, here is for understanding purpose I am solving examination. Please don't do direct steps. You need to write all the steps. So I'll be writing all the steps in one diagram only, spanning tree, but you have to write it all the steps step by step. First one, which one you have taken. Second one, at least Prim's algorithm, if you have 7 to 8 nodes, you have to take at least 4 to 5 steps. You have to write it, which one you have taken first and which one you have taken next. So then, okay, last 2 to 3 steps you can combine based on your timings. That's it. But if you write it entire in one answer, you will not get good marks. Are you getting what I'm saying? Now I will be solving the spanning tree here only. So here is, already I told you, first node to be taken when you are solving the Prim's algorithm. So Prim's algorithm, when you are taking this, so 5 is there, 3 is there, 4 is there, which is the minimum that to be taken. So A to C is the minimum. So actually A to B 5, A to C 3, A to D 4. Now you have taken this one. Next, what will happen? So from C, you have to write it what are the outgoing nodes. So C to B is there 6, C to D 8. So what will happen? Now out of all these things again, which is the minimum? So 4 will be the minimum, and you need to take the 4. So A to D. A to D. So from D outgoing nodes, you have to write it again. D to E is 7. D to E is 1. Again, out of all these things, which is the minimum? So 1 will be the minimum. So D to E to be taken. So this one to be minimum. Now you write it from E outgoing nodes. E to B is there 2. So C to B we have written. C to D we have written. C to E also I have supposed to write. I have not written there. But C to E is 7. C to E is 7. Now, which is the among all those things, minimum is nothing but 2. That is nothing but the E to B. Next, again, which is the minimum is nothing but 5. So A to B, if I draw, you will be getting the cycle. So that is not possible, not possible to be taken. Next, again, which is the minimum is nothing but you have the 6. C to B. C to B, if I draw, I will be getting the cycle. Not possible this. Next is 7. So that is called C to E. If I draw this, I will be getting the cycle. Not possible. Next to C to D. If I draw this, that is also I will be getting the cycle. Not possible. So this is what the final diagram, and you need to write it 3 plus 4 plus 1 plus 2. That cost you have to write it final answer. 3 plus 4 plus 1 plus 2. So that means 7, 8, 10. Minimum cost spanning tree is 10. That is what you need to write it in the examination. Right. The next one is the same diagram. I will be writing the Kruskals also. Kruskals algorithm. The same diagram will be taken. Now what you have to do is first you have to make the ascending order first. I told you. So now what you have to do is D to E is 1. Next is B to E 2. Next is 3A to C. Next is 3 over 4 is A to D. Next 4 over 5 A to B. Next is 6. 6 is there, B to C. Next 7 C to E. Sorry, 7. Next is 8 C to D. This is what you have to write an ascending order. Now you write the spanning tree for this. A, B, C, D, E. So now what will happen? Which is the minimum? First one is D to E. So D to E, you draw it first. This is called 1. Next. Next one is B to E 2. Yes, that to be drawn. Next is A to C 3. A to C 3. I'll write it. So one more diagram. I'll write it. A, C, D, B, E 1, 2, 3. So now this one over. Now A to D is 4. Now I can take A to D also 4. Next 5 is there. 5 is A to B. If I draw, I will be getting the cycle. Next B to C. If I draw, I will be getting the cycle. C to E 7. If I draw that, I will be getting the cycle. C to D. If I draw, I will be getting the cycle. So this is not possible. This is what the cost. So the answer is D to E is 1, B to E 2, A to C 3, A to D 4. Now what will happen? Minimum cost of spanning tree is nothing but how much? 10. Now the same Dijkstra's algorithm also. Same Dijkstra's. Are you following? Hello, students. So now today's class you will listen
Yes,
carefully.
sir.
Why
Following.
means tomorrow, day after tomorrow you have examination now. So now you will be listening carefully. You will understand very clearly in today's class. I hope. Okay, right, sir. Now the same thing, Dijkstra's algorithm. Dijkstra's algorithm, the same diagram. I'll write once again this diagram. Yes, I have to go to that page and it is difficult. A, B, C, D, E. So now what will happen? This is 5, 3, 4, 8, 6, 2, 7. This is called 1. So examination. Oh, again the shadow came. Have to lift the pen and I have to write it. The space, there is a problem. Right, sir, no problem. So now what will happen is Dijkstra's algorithm is nothing but we have to find out A to B, which is the minimum. So now directly I'll write the answers. Right. So in this case, what will happen? A to B, first you have to find out which is the minimum. A to B, A to C, A to D, and A to E. So directly I'll write the answer here because you know how to solve these problems already. Just for understanding purpose, I'm telling. So A to B, you have the 3 ways are there. So A to B directly 5 is there. Another route is A to C, C to B. Another route is A to D, D to C, C to B. So all these things with respect to that, A to B only will be the minimum cost. Next, that is what the 5. Next, A to C is nothing but you need to check it out. So A to B, B to C also 5 plus C is 11 it will be coming. So A to C is directly root is there, that is called the 4 only. Next, A to D is there. D different routes are there compared to the direct route only shortest path.
Sir, A to C3.
Right, sorry. Right, A to D is 4 only. Right. So now what will happen? You need to check it out. This is also 3. This is 4. Next is A to E is there. So A to E you have different paths already recently visited nodes. A to B is there, A to C is there, A to D is there. Now from there you need to take any one, which one will be the least cost for this matrix. So here is what will happen. 7 is there. This one is, if I'll rewrite this one 7, if it is not visible here. 7, 3 plus 7, 10, 7, 5 plus 2, 7, and another one is called 4 plus 1, 5. So which is the least one is nothing but the 4 plus 1. So that one to be taken. So that is called the 1. Now this is called the 1. Now what is the value here? Cost is minimum cost. For 5 plus 3, 8, 8 plus 10, 8 plus 1, 5, 10, 13. What is the cost? Correct, 13. Minimum cost spanning tree is called here 13. Now what will happen? See here, this is called 10. Now this is called also 10 only. This one is 13 you got, this is called 10. So now the same related problem only have given the questions. So now you need to justify this answer in the examination. I'll give you the case study question. I'll send it to your mail IDs, that related case study. So what my question is saying, so you are solving this Prim's algorithm, this spanning tree is, you will be getting, you are starting with which node here? Prim's is nothing but starting node only. Dijkstra's also, I'll be telling the starting node is first. You are drawing here also spanning tree, and here also drawing the spanning tree. So are you getting the same? Are you getting the different? So you need to justify which one will be the best for the to draw the spanning tree, either Dijkstra's or Prim's algorithm. That is what your case study question. So if they are asking some different question, different way, so that is what they briefly I told you. So you need to compare these two. You need to understand the question, and if they given the example problem, you solve it that one. If they're not giving, you take your own example and solve it. So I have taken here one example, and this one I have got this answer, and the same problem when I'm solving this, I'll be getting this answer. Now how you will be comparing? Even though you are starting with starting node here also A, and here also you are started with A, starting node is A, but you got this answer here, and here you got different answer. So now which one will be the best to draw the spanning tree? That is what you need to write the conclusion. So case study question is nothing but you need to understand all the problems. You need to write the perfect answer, which one will be suitable for this. So that is what the innovative case study question, almost direct problem only. So be either Prim's, crystals, or Dijkstra's. So Hoffman code. So any one problem I'll be asked bit differently. So way of solving is same only. Hoffman code. Suppose if I take Prim's algorithm means, so in a given network, how will be drawing the minimum cost spanning tree? Suppose if it is Hoffman code, encode and decode, something differently I will be asking, but the question will be the same only. Okay. So innovative is that like that only. That is what innovative differently. So instead of directly solving Hoffman code, I will be giving one text and I will be giving the code. So convert this to or encode the following text to binary form, something like this. So for this, construct the binary tree using the following diagram. So something like this I will be asking for the innovative and case study questions. So case study question, I will share it now here. Case study and case. So Indian Institute of Technology Design and Manufacturing. So some of they have given this greedy algorithm part 2, interval scheduling. So how they will be solving, you see the input output, how they were told. So because strategies will be how strategy 1, strategy 2, strategy 3, reason 1, 2, 3 they have given, what are the questions they have given. So you see how they will be solving their problems. You read it, and this one network they have taken, and with respect to mathematical, how they have done it. That's what the case study, minimum of the weight spanning trees. So Krushkals also they have given, and procedure for the corrections, and some of the thoughts what they have got it. Minimum cost spanning tree they have written. You see here everything with respect to graph only they have explained it. This is what the technology for the how they have done IISCs and all. So IITs, IISC students, how they will be solving. That is what the bright students. So you see here, I have solved it and read it this. This is what the case study questions have given it. So I'll share this through emails also today after this class, and we can discuss. These were the any now any other problems I can be able to solve. Augmentary, I hope now time is not allowed to do it that one. And sorting by counting, already yesterday only have told you up to here. Sorting by counting also is there for the second internals. I have given question already for that also. Sorting by counting. So any algorithm students, I'm telling you DFS, if they give apply DFS also, you have to you need to write the algorithm for this BFS, DFS, prims, Kruskals, whatever it may be. I told you the graphs and open the textbook once again and try to solve it. So whatever I have done it today, I'll send PDF file for this. It will become I can convert it PDF format here. I'll convert it and case study file, and this one I'll send it today. Okay. So any doubts with respect to test, second test, you need to ask me. So here is all marks is in your hand. So you distribute your timings properly. You need to solve before coming for the examination, because you will not get whatever I have solved in the class or whatever I have given the homework. So I have taken the different problems. So you cannot copy it. Algorithm may be possible to copy that one. The problems is nothing but what will happen. You need to solve it. So before coming for the examination, before writing for the examination, please solve one or two problems with respect to all. What I have told you, BFS, DFS, topological sorting, and prims, Kruskals, Dijkstra's, Hoffman code, sorting by counting, all one problem, whatever have given in the class to solve it, you do it. So that it will be the best. Now I'll give you one problem. Please solve it this. A, B, C, D, E, F. Right. So then the values are 1, 2, 3, 4, 5, 6, 7, 8. This is 4. So apply prims, Kruskals, Dijkstra's algorithm. So solve it so that you will be getting almost 20 marks if you are perfect to solve this problem. Okay.
Sir, A to C, it is 12.
Sorry, 2 only. Shall I rewrite once again? That this one. Can you able to see this? This one.
Yes, sir. Yes, sir.
So this marker is. I will show you 1 second.
A to T bardila.
Sir, what about C to D?
See, when I'm seeing this marker, this one is shadow comes also. It is drawing. Now I have to put the finger there. Then it will not be coming proper. It will come properly. Okay.
Yes.
So I'll draw it once again. No problem.
Sir, C to D also. Is good.
Yes. Same diagram. I'll copy it once again. A, B, C, D, E, F. One, two, three, 4, 8, 7, 6, 5, 3. Okay, now is clear diagram?
Yes, sir.
All right. So here is what you need to do is, suppose examination if miss any one value, so main examination also or internal examination also, you can contact your respective teacher, or in main examination also, whoever invigilator is there, you tell it one value is missing, so they will find out. If it is available, they will tell it, otherwise you can assume and do it. So in that case, you assume that one and you solve it. Don't say one value is not there, I cannot solve it. So C to D, for example, a previous diagram I have not entered, somebody asked. So C to D value has not given, so I'll be assuming 5 or 6, write it. Based on this, the spanning tree as follows, you write it and solve it and tell it the answers. Okay, right, shall I stop now? It is ADA03. Right, I'll send this if you want. Do you want details problems? Answer attendance 1,
Present, sir.
2, 2, 3,
Present, sir.
4,
Yes, sir.
5,
Present, sir.
6,
Yes, sir.
7,
Present, sir.
8,
Yes, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15, 16,
Present, sir.
17,
Present, sir.
18,
Present, sir.
19,
Present, sir.
20, Guriya Kumari, 21, 21, 22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Yes, sir.
26,
Present, sir.
27,
Yes, sir.
28,
Present, sir.
29,
Yes, sir.
30,
Present, sir.
TD series 2,
Present, sir.
3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
6 present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Yes, sir.
12,
Present, sir.
13,
Present, sir.
14,
Yes, sir.
16,
Present, sir.
17,
Yes, sir.
18,
Present, sir.
19, Srinidhi, Srinidhi absent. Okay. 20,
Present, sir.
21,
Present, sir.
23,
Present, sir. 22 present,
okay,
sir.
23%. Okay. So all the best for examination. Do well. If anybody is staying nearby, if you come to my cabin, I will give you the notes. You can take snapshot or you can convert into PDF and you can send it to other people. So that's what I can do it. I'm having notes also, but how to send it, that is a problem. If library it is available, if they're converting like first test, if they give it, I'll send it. Otherwise, if anybody is staying nearby, you can come and collect the notes.
Sir, today whatever you did, no, you send it, send us, sir. Today whatever you did.
I'll send it now only. I'll send it.
Class now.